Hi, my name is Anish Aradhey, and I'm from Harrisonburg, Virginia.
Hi, my name is Anisha Krishnamoorthy, and I'm from Miami, Florida.
Hi, my name is Rajasi Kolhatkar, and I'm from Houston, Texas.
Hi, my name is Ortiz, and I'm from Dallas, Texas.
Hi, my name is Meera, Ravi, and I'm from Austin, Texas. Our astrobiology project studied extremophiles on Europa.
Extremophiles are organisms that thrive in extreme conditions. Because of their resilience, it is plausible that some could tolerate extraterrestrial environments. Our research asks, which extremophiles could survive on Europa? Our study could help us better understand the possibility of extraterrestrial life by connecting our knowledge of extremophiles with astrobiology.
In our research, we first explored various celestial objects and selected one to study further. We then identified the conditions at that location, including temperature, humidity, and radiation. Finally, we researched and identified extremophiles that could survive in these conditions.
We chose to study Europa, a small moon of Jupiter, because it is one of the most promising places to find life in our solar system. It has a thin oxygen atmosphere, and its surface is covered with a water ice crust. The potential for extraterrestrial life is found beneath this crust, where scientists have found strong evidence of a vast salty ocean of liquid water, which is shown in the lower image. Past spacecraft observations have suggested that plumes of water are ejected through Europa's crust, which could be caused by geological activity. This could provide the energy needed for life to develop.
Europa's surface is very cold, reaching lower than -350 degrees Fahrenheit, and is exposed to amounts of radiation that would be instantly fatal to humans. However, Europa's liquid water ocean has a very warm temperature of 39 degrees Fahrenheit and very little radiation exposure. Europa's water pressure ranges from 130 to 260 megapascals, and its oceans are very salty and acidic, with a pH of 2.6.
By comparing microbes with these conditions, we determined which extremophiles could potentially survive on Europa. The first microbe is Deinococcus radiodurans. This bacteria can survive massive amounts of radiation because it has multiple copies of its genome and rapid DNA repairing abilities. This microbe can also withstand acidic environments and temperatures of 37 degrees Fahrenheit. This bacteria has even survived 3 years outside the ISS in the module shown in the lower image.
Another extremophile that could survive life on Europa is Coelia cicatrarea, a bacteria that thrives in cold temperatures. It grows between 30 and 36 degrees Fahrenheit, thrives in high salinities, and withstands between 60 and 140 megapascals of water pressure, which all match the conditions of Europa's ocean. While only 2 extremophiles fully matched our criteria, others came very close.
Natrialba magadi is an archaeon that thrives in hypersaline liquid environments. It has a special cellular structure that uses charged amino acids to prevent dehydration. It is considered an alkalophile because it can withstand pH levels as high as 9.5. In past experiments, it has survived some conditions similar to those on Europa. However, this microbe thrives in temperatures and pH levels much higher than those on Europa.
Sulfovus shabati is an archaeon that utilizes magnesium and sulfur to synthesize simpler compounds. Both of these elements have been predicted to be plentiful on Europa. This microbe also survives in pH levels as low as 2. In experiments, it has survived conditions similar to Europa's. However, it thrives in temperatures that are much warmer than those on Europa.
Our research has multiple applications. Learning about which microbes could potentially survive on other planets helps us better sanitize spacecrafts, as shown in the right image. By doing so, we can ensure that life from Earth doesn't contaminate other celestial bodies. The microbes we researched could also be used to determine what types of life to look for future space missions. Finally, the genetic traits of those extremophiles could have applications in bioengineering.
We would like to thank our mentor, Ms. Henry, all of the guest speakers, Ms. Miller and Ms. Baggio, for making SEAS possible. Here are our references.
The highlights of our internship included researching new subjects like Europa and learning from scientists. One challenge we had to overcome was negotiating amongst ourselves. Here are our individual reflections on our internship experience. Thank you for listening.